Section 1.2 Subsets, Video 3. In this video, we will cover the following objective. Count the number of subsets and proper subsets of a set. We will start with an example. Suppose that we would like to order a pizza and we have a choice among 5 different toppings. And I'm going to abbreviate the I'll write the toppings out, but then I'm going to abbreviate them. So let's say that we can get green pepper, mushrooms, olives, pepperoni, or sausage. And say that we can opt to get no topping, or 1 toppings or 2 toppings, etc., or maybe even just all 5. The question is, how many different pizzas can we create given these choices? And basically what this boils down to is counting the number of subsets of this set, the set containing these 5 toppings. So if we got a pizza without any topping, then that would be represented as the empty set. So that's one choice. Now we could get a pizza with just green peppers, or just mushrooms, or just olives, just pepperoni, or just sausage. So those would be like a collection of 1 topping pizzas. Then we could find a collection of different 2 topping pizzas. So for example, we might get green peppers and mushrooms, or green peppers and olives, or green peppers and pepperoni, or green peppers and sausage, etc. So I'm going to continue to write these out. I'm not going to say them all. The last one would be pepperoni and sausage. So those are all the different collections of 2 topping pizzas that are possible. And then we can move on and we can talk about different 3 topping pizzas. For example, green peppers, mushrooms, and olives would be an example of a 3 topping pizza. And we can keep listing these 3 topping pizzas, but for the sake of time, I'm not going to continue with those. And then we can look at the options for 4 topping pizzas, like green peppers, mushrooms, olives, and pepperoni would be one example of a 4 topping pizza, etc. And then I don't have a whole lot of room, so I'm going to write it here. The last option would be to get a pizza with all 5 toppings. So we'd have to fill in some of those blanks there. I didn't list all the 3 topping or 4 topping pizzas. But if we were to continue the list and write this full out, we would be able to count the number of possibilities, and we would count that there are 32 different pizzas that can be ordered given this set of 5 toppings. So in the end, we would see that there are 32 options. Now, in a problem like this, it would be easier to have some sort of a formula to help us count the number of possibilities as opposed to listing them all out and then counting them that way. And it turns out that such formula does exist. And this, again, is basically finding the number of subsets of a given set. And it turns out that if we take 2 and raise it to the power of the cardinality of the set, so the number of elements in the set, that would give us the number of subsets. And in this case, if we have 5 different toppings that are possible, if we take 2 to the 5th power, that would be 2 times 2 times 2 times 2 times 2. That would give us 32 different options. So if we have a set with no elements, then that formula would be 2 to the 0 power, which is 1. If we have a set with one element, then the number of subsets would be 2 to the 1st power, which is 2. If we had a set with 2 elements, then we would have 2 raised to the 2nd power, which is 4 subsets. And you can see that they're listed here, all 4 of them. If we have a set with 3 elements, 2 to the 3rd is 8, which means that there would be 8 subsets, which you can see them all listed there. And so this formula will allow us to count the number of subsets of a given set. Now, we can also find the number of proper subsets. Recall that a proper subset is a subset that is not equal to the original. So if we took the set A, B, C, and if we looked at those 8 subsets, the first 7 would be quote-unquote proper subsets. The last one would not be because it is equal to the original. So that last subset listed there would not be called a proper subset. Or if we had the set with just A and B, and we listed the 4 subsets, the first 3 of them would be proper subsets. The last one would not be, again, because it is equal to the original, and therefore it is not a proper subset. So notice that if we were to calculate the number of subsets, the number of proper subsets will always be 1 less than that. We're removing the set that is the subset that is equal to the original set. Okay, so counting the number of subsets of a set. If a set contains n elements, then the set will have 2 to the n subsets. And we can use this to count the number of proper subsets of a set. If a set contains n elements, then the set will have 1 less, so 2 to the n minus 1 proper subsets, as we just saw above. Example 4. Count the number of subsets and proper subsets of each set. Part A. We have the set Brewers, Cardinals, Cubs, Pirates, and Reds. So we have 1, 2, 3, 4, 5 elements. So therefore there will be 2 to the 5th power, or 32 subsets. And those 32 subsets would be made up of a collection of, starting with the empty set and ending with the set containing all of those baseball teams. And then we would have all the options in between. We'd have subsets that only contain 2 teams, subsets that contain 3 teams, subsets that contain 4 teams. And if we counted all the options, we would get 32. There are 31 proper subsets, 1 less. We would have to remove the subset that is equal to the original set itself in order to calculate the number of proper subsets. Part B, we have the set of all x given that x is an element of the natural numbers and x is between 10 and 20, not including 10 and not including 20. So what I would like to do first of all is maybe write this in raster method. So we're looking at the natural numbers starting with 10. So we have 10, 11, 12, 13, 14, 15, 16, 17, 18, and then we're ending at 19. So in order to find the number of subsets, we're going to take 2 and we're going to raise it to the cardinal number of this set. So in other words, I have to count the number of distinct elements in this set, which there are 10 elements in this set. So we would take 2 and raise it to the 10th power, which would give me 1,024 subsets. And therefore, we would have 1,023, one less, proper subsets. This concludes example 4.